Okay, you've got your finger in so many different advanced technologies. Are you sincerely trying to save the world?
Well, I'm trying to do good things, yeah.
Imagine you're having a conversation with Grok, the artificial intelligence created by Elon Musk. On a holographic screen, Grok flashes that familiar grin and says, "Elon is always telling us that we have to do what's right for the planet. But sometimes, the right path takes us in a direction nobody saw coming." And that's exactly where the story of Tesla's so-called water engine begins. At first, the whole idea sounds completely crazy, but now it's making people across both the auto industry and the renewable energy world stop and think. For years, Tesla has basically been the symbol of transportation electrification. Lithium-ion batteries, ultra-fast superchargers, and high-performance electric vehicles have all become part of the Tesla identity. But lately, rumors that Tesla may be testing a hydrogen engine using water injection technology have started creating a lot of buzz among engineers and investors. If those rumors turn out to be true, Tesla wouldn't just be changing how its cars are powered. It could potentially rewrite the entire idea of what an environmentally friendly vehicle is supposed to be. A company that once mocked hydrogen fuel cell cars could now be trying to redefine hydrogen through a completely different approach. Elon Musk has always been known as someone who's stubborn, confident, and not exactly quick to abandon his opinions. In the past, he called hydrogen mind-bogglingly stupid, arguing that it was inefficient and impractical. So why would Musk change his position now? Maybe the answer comes down to the way he tends to think about progress. You don't change direction just to correct a mistake. You change direction because you want to keep moving forward. If hydrogen can be burned directly while water injection is used to control the combustion process, then Musk wouldn't necessarily be abandoning what he believed before. Instead, he could be opening the door to an entirely new era. And the inspiration may be coming from Europe. Austria's AVL Racetech, along with a laboratory in Hungary, recently announced a hydrogen engine that uses water injection. According to the figures being discussed, a 2-liter engine can reportedly produce around 410 horsepower, which works out to roughly 205 horsepower per liter. For an internal combustion engine, that is an incredibly impressive number. The secret is injecting water directly into the intake, which cools the mixture before it enters the combustion chamber, helps prevent premature ignition, and allows the engine to operate under much higher loads. When combustion temperatures are kept under control, the compression ratio can be increased, combustion becomes more stable, and overall efficiency improves. The result is an engine that can make serious power while keeping emissions extremely low and dramatically reducing the risk of knock. Tesla, meanwhile, has built a reputation for spotting promising technologies quickly and finding ways to integrate them into its own ecosystem. But the biggest difference between Tesla and companies like AVL, or traditional engine developers in general, is that Tesla already has an entire platform built around electric motors, batteries, software, the supercharger network, and energy storage. If a water-injected hydrogen engine were added to that architecture, Tesla could theoretically build a vehicle that delivers the instant response of an electric motor, while also offering the long-distance capability of hydrogen fuel. In other words, 2 or even 3 different energy systems could potentially work together inside the same vehicle. Take the Model Y Juniper as an example. It's currently being discussed with power output of around 456 horsepower. According to some of the speculation circulating online, adding a hydrogen system could push total output beyond 520 horsepower. 0 to 60 mile/hour acceleration could potentially fall to around 2.8 seconds. Torque could increase by more than 10%, and battery life could even improve significantly. If all of that ever became reality, you'd be looking at a vehicle that was powerful, efficient, and environmentally friendly at the same time. But the most interesting part about Tesla isn't necessarily the engine itself. What makes the company different is the way it tends to redesign the entire energy ecosystem around the vehicle. Most automakers would focus mainly on the engine or the drivetrain, but Tesla is rumored to be considering turning its existing supercharger network into something like an H-supercharger network, where stations wouldn't just charge batteries, but could also produce hydrogen on-site by electrolyzing water with renewable electricity. That electricity could come from solar power or cheaper off-peak grid electricity, then be stored in megapacks before being used for electrolysis. In that kind of scenario, a driver could pull into a familiar Tesla station and potentially charge the battery and refuel with hydrogen in around 5 to 10 minutes. After a long trip, there would be less concern about battery heat, degradation, or spending hours waiting for energy. Range anxiety could also become much less of an issue. If Tesla actually managed to build something like this, it could become the company's second major transportation revolution after the rise of the electric vehicle. Hydrogen, a technology Musk once treated as outdated, could come back in an entirely new form. By redefining the relationship between electricity and hydrogen, Tesla could move toward a generation of vehicles that are more powerful, travel farther, and are more sustainable, while still staying connected to the transportation electrification philosophy Musk has been building from the beginning. That's why investors are starting to ask a bigger question. Is this just some kind of laboratory experiment, or is Tesla seriously considering putting this technology into future products like the Model 2 or the Semi? If it's the second option, then we're no longer talking about a simple technical upgrade. We're talking about an evolution in Tesla's entire philosophy of energy. Within the engineering community, some people have already taken data released by AVL and used it to build simulations. Based on those analyses, water injection in a hydrogen engine could lower combustion chamber temperatures by roughly 20 to 25%, allowing a higher compression ratio, improving efficiency, and still reducing the risk of knock. Combined with Tesla's electric motors, the advantage becomes even more obvious because an electric motor can generate maximum torque almost immediately from 0 revolutions per minute. That's something a conventional internal combustion engine simply can't match. From a mechanical standpoint, this would almost look like the comeback of the internal combustion engine, except in a cleaner, smarter form that is heavily supported by software. To make the comparison easier, look at the current Model 3 long range. In the assumptions discussed in the original material, the car is said to consume around 25 kilowatt-hours per 100 kilometers, while delivering a range of around 358 miles. If an electric hydrogen hybrid system with water injection were added, energy consumption could theoretically fall to around 20 kilowatt-hours per 100 kilometers, while range could climb beyond 410 miles. That would put it ahead of some competitors like the BMW i4 eDrive and Polestar 2 in terms of driving distance. And if the thermal management system could remain efficient across temperatures ranging from -10 degrees Celsius to 45 degrees Celsius, cold weather performance could potentially become much more stable than it is in a typical battery electric vehicle. That matters because lithium-ion batteries can lose a noticeable amount of efficiency when temperatures fall. The affordable model many people refer to as the Model Q also keeps showing up in these rumors. Its expected price of under $25,000 has led some people to describe it as a true car for the masses. According to unconfirmed information, it could use a battery of around 45 kilowatt-hours paired with a hydrogen assist system rated at roughly 100 kilowatts. That could potentially give it more than 350 miles of range, while hydrogen refueling might take only around 5 minutes. If that scenario ever became real, affordable EVs like the Chevrolet Bolt and Nissan Leaf could suddenly be facing a very serious competitor. A low-cost vehicle with long range and extremely fast energy replenishment would have a major impact on the mass market segment. In commercial transportation, the Tesla Semi could potentially make an even bigger difference. The current Semi is often discussed with a battery capacity of roughly 1,000 kilowatt-hours and a range of around 500 miles. But in a hydrogen hybrid scenario, energy consumption could reportedly fall by roughly 20%, while the hydrogen system could add several hundred miles of additional driving range. Total theoretical range could exceed 1,100 miles. By comparison, a diesel-powered Freightliner Cascadia typically operates somewhere around 700 to 750 miles in comparable configurations. More importantly, refueling hydrogen could be significantly faster than charging an enormous battery pack. Some estimates even suggest that trucking companies could save between $15,000 and $20,000 per vehicle every year if the system actually delivered the efficiency being predicted. What makes the idea even more interesting is how all these pieces could theoretically fit together into one unified structure. Modular hardware, over-the-air software control, hydrogen safety sensors, water injection cooling, and a central controller could all work together like organs inside the same body. Under this vision, Tesla wouldn't simply be building another new vehicle. It would be creating an intelligent hybrid energy ecosystem where the Model 3, Model Y, and Semi could share major hardware components, reducing component costs and optimizing the supply chain. That's why some analysts look at the so-called water engine not simply as an experimental technology, but as a possible long-term survival strategy. As Tesla faces increasing pressure from new competitors in the EV market, expanding into hydrogen could give Musk a way to create an entirely new game instead of continuing to fight everyone else on an increasingly crowded playing field. If the first generation of Tesla helped open the era of mass-market electric vehicles, a future hydrogen hybrid generation could be marketed as a rebirth of both speed and sustainability. A water-injected hydrogen engine wouldn't just be another part added to the car. It could force Tesla to completely redefine the way it thinks about transportation. The company would no longer limit its thinking to batteries and electric motors alone. Instead, it could start combining mechanical power with intelligent energy management. Anyone who has driven a Model Y knows that strange sensation of acceleration, almost like the car is being launched forward by a giant rubber band. In a hypothetical hybrid Juniper version, that feeling could be pushed even further. A dual-motor system combined with water injection could keep the powertrain within its ideal temperature range and reduce performance loss when the battery gets either too hot or too cold. According to numbers currently circulating, peak output could exceed 520 horsepower, torque could pass 550 pound-feet, and 0 to 60 mile-per-hour acceleration could come in at around 2.8 seconds. If that were true, the vehicle could potentially outrun some versions of the Porsche Taycan that cost almost twice as much. While many high-performance EVs can lose power when their battery packs get too hot after repeated hard acceleration, a hydrogen-assisted system could theoretically help with thermal management, allowing performance to remain consistent for longer while reducing stress on the battery. Some sources have even suggested that useful battery life could increase from around 36 months to 48 months or more, depending on how the vehicle is used. Those figures still need confirmation, but the main idea is simple. Hydrogen wouldn't be there to replace electricity. It would be there to take some of the load off the electrical system. The Model 3, one of Tesla's signature products, could also see major changes, even if it looked nearly identical from the outside. In the original material, the current version is described as producing roughly 175 kilowatts and consuming about 25 kilowatt-hours per 100 kilometers. Add a hydrogen module, and output could theoretically rise to 200 kilowatts, while overall efficiency improves by around 20%. That would mean a Model 3 that is both stronger and capable of traveling farther. With one hydrogen fill-up and one battery charge, theoretical range could exceed 410 miles. The ability to stay efficient across temperatures from -10 degrees Celsius to 45 degrees Celsius could also make a huge difference in cold regions, where regular electric vehicles can lose 20 to 30% of their energy just heating the battery and passenger cabin. But the model that may attract the most attention is still the Model Q. A lot of people see it as Musk's last major affordable car project, the one that could finally bring Tesla to the true mass market. If the price really came in below $25,000 and hydrogen hybrid technology were included, it could become the first vehicle to bring this kind of system to a very large number of consumers. Leaked information being discussed suggests that it could use roughly a 45 kilowatt-hour battery paired with a 100 kilowatt hydrogen module, giving it more than 350 miles of range. 0 to 60 miles per hour could reportedly take around 5.2 seconds, making it significantly quicker than a lot of vehicles in the same price bracket. While charging at home from conventional electricity can take many hours, hydrogen refueling could theoretically take around 5 minutes. If the technology really worked that way, this wouldn't just be a numbers competition. it could become a strategic challenge to cars like the Chevrolet Bolt, Hyundai Kona Electric, and Nissan Leaf. Back to the Tesla Semi, the issue isn't really about speed or power anymore, it's about economics. The Semi is currently discussed with a battery capacity of around 1,000 kilowatt-hours, a 500-mile range, and energy consumption that can reach roughly 2 kilowatt-hours per mile under heavy loads. In a model using a water-injected hydrogen engine, that figure could theoretically fall to around 1.6 kilowatt-hours per mile. That could allow the truck to travel around 600 miles using battery power, then add another 500 to 600 miles from hydrogen, pushing total range beyond 1,000 miles. For logistics companies, that kind of improvement could be extremely valuable because every minute a truck sits still costs money. If energy replenishment time fell from around 30 minutes to roughly 8 to 10 minutes, each truck could spend more time actually moving freight. And if each refueling event saved around $35 to $50, annual savings could potentially reach $15,000 to $20,000 per vehicle. With fuel prices constantly moving up and down and carbon regulations becoming increasingly strict, a difference that large could influence investment decisions across the entire transportation industry. But no matter how impressive a technology looks on paper, it doesn't mean much if it can't scale. Tesla understands that better than almost anyone, so in the scenario people are discussing, the company wouldn't just need to build a new engine, it would also have to build the infrastructure required to support it. Using the existing supercharger network as a foundation, Tesla could theoretically create a dual-purpose station called the H Supercharger. At these locations, electricity wouldn't only charge vehicle batteries, it would also power water electrolysis equipment that could produce hydrogen directly at the station. The electricity could come from solar energy or cheaper off-peak grid power and then be stored in megapacks. When drivers arrived, they could choose battery charging, hydrogen refueling, or both depending on how the vehicle was configured. In theory, this setup could also reduce stress on the power grid during peak hours because excess electricity generated or purchased at other times could be converted into hydrogen and stored for longer periods. When needed, that hydrogen would become an additional energy source for transportation. You'd end up with a circular model. Renewable energy creates electricity, the electricity is stored in batteries or converted into hydrogen, the hydrogen is used in the vehicle, and software decides which energy source makes the most sense at any given moment. That is exactly the kind of ecosystem Tesla has historically preferred to build, instead of simply selling a single standalone product. On the safety side, the hypothetical system is described as using a multi-layer active protection architecture. Pressure sensors, temperature sensors, and leak detectors would be installed throughout the hydrogen plumbing. If something unusual happened, the system would be designed to react almost instantly. In an emergency, safety valves could isolate or vent the fuel away from dangerous areas to reduce the risk of fire or explosion. Water injection wouldn't only improve efficiency, it could also work as a thermal buffer, keeping combustion temperatures within a controlled range. That would fit Tesla's engineering philosophy pretty well. Instead of relying entirely on heavy mechanical barriers, the company could use sensors and software to actively monitor, predict, and respond to risk. Software, then, becomes the heart of the entire system. Through over-the-air updates, Tesla could theoretically adjust ignition timing, water injection ratios, electric motor assistance, and thermal maps depending on local environmental conditions, or even hydrogen purity. If the vehicle were operating in extremely cold or extremely hot conditions, algorithms could automatically adjust the system to maintain performance. Even when outside temperatures ranged from -10 degrees Celsius to 45 degrees Celsius, the goal would be to keep the driving experience consistent. Owners wouldn't need to visit a service center just to have the engine recalibrated for seasonal conditions because Tesla could optimize much of the system remotely. That would be extremely difficult for traditional engine manufacturers to match if they didn't have a deeply integrated software platform. On the manufacturing side, this architecture is also imagined as highly modular. Electric motors, inverters, the central controller, and a rear hydrogen module could potentially be designed for use across the Model 3, Model Y, and Semi wherever practical. That could allow Tesla to reduce the number of unique components, shorten assembly time, and continue using much of its existing supply chain. After the pandemic, dependence on China for batteries and battery materials became a major strategic concern for many Western manufacturers. A hydrogen hybrid model could potentially provide another way to diversify energy sources. Instead of putting nearly the entire future of transportation into one battery chemistry and one mineral supply chain, Tesla could spread its energy requirements across multiple technologies. The economic impact for private owners could also be substantial. If the battery went through fewer high load cycles, its usable life might increase, while the time needed to replenish energy could fall. In some scenarios, total cost of ownership could potentially decline by around 12 to 18%. For commercial vehicles, the benefit could be even larger because trucks could operate for more hours each day and spend less time sitting still. For Tesla, every H supercharger could also become more than just an energy station. It could become an actual energy business hub. Tesla could sell electricity, sell hydrogen, store energy, and even participate in grid balancing from the same location. At that point, Tesla would no longer simply be making money from cars. It would be operating a complete energy ecosystem. What's interesting is that Musk may have learned something from the earlier failures of the hydrogen industry. He could have realized that the real problem isn't necessarily hydrogen itself. The problem may be the ecosystem around it. If infrastructure is too expensive, hydrogen production is inefficient, and safety problems aren't addressed, then the technology will struggle to compete. But if cost, infrastructure, and control systems improve, hydrogen could become a useful piece of a low-emission transportation system. If Tesla actually entered this space, it couldn't just talk about an engine. It would have to solve all of those surrounding problems at the same time. Some engineers in these unverified descriptions reportedly refer to the idea as ecosystem alignment. The electrolyzer, battery pack, sensors, software, electric motors, combustion engine, and mechanical structure would all have to operate like parts of the same neural network. Nothing unnecessary, nothing there just for show. Every component would serve a specific purpose and exchange data with the others. That's also one of the things that has made Tesla different over the years. The company doesn't usually look at technologies as completely separate pieces. It tries to turn them into a living system where software continuously adjusts hardware based on real-world data. On a global scale, Tesla entering hydrogen could mean much more than one technology project. A number of countries in Europe and Asia have been investing heavily in hydrogen. Spain, for example, accounted for a significant share of new European hydrogen projects during the early 2020s. If Tesla entered the market with a large number of hydrogen-capable vehicles, a network effect could begin to develop. The more hydrogen vehicles there are, the greater the incentive to build infrastructure. As the infrastructure grows, the cost of producing and distributing hydrogen could potentially fall. Lower costs could then encourage more people to buy the vehicles. If the whole chain worked efficiently, it could become a positive feedback loop. More importantly, Tesla in that scenario wouldn't simply be an electric car manufacturer anymore. It would become an integrated energy company, where vehicles, batteries, charging stations, storage systems, and the electrical grid are all connected. Over roughly the last 20 years, Musk has become one of the most influential figures in the development of the modern electric vehicle. Tesla went from a startup that a lot of people laughed at to a company worth hundreds of billions of dollars, while forcing nearly every major automaker to create its own electrification strategy. But as competition in the EV market gets tougher, Tesla faces a familiar question. How do you stay ahead once everyone else has learned how to play the same game? That's one reason the hydrogen rumors are attracting so much attention. As Tesla's EV market share came under pressure in some markets during 2024, falling from levels that had once been above 60% to significantly lower levels, Musk undoubtedly understood that leadership can't be protected by simply repeating what the company has already done. Tesla has to keep creating things that even Tesla itself might not have imagined a few years earlier. And ironically, one of the directions people are now talking about is hydrogen, the very technology Musk publicly mocked in the past. On multiple occasions, Musk has used the phrase "fool cells" as a joke about fuel cells. He has been especially critical of hydrogen's energy conversion chain. Use electricity to produce hydrogen, compress or liquefy it, transport it, and then turn the hydrogen back into electricity inside a vehicle. Every stage wastes some energy, which can make overall efficiency significantly worse than simply charging a battery directly. Battery electric vehicles using lithium-ion batteries can achieve much higher efficiency from power source to wheels, but the water-injected hydrogen system being discussed here wouldn't follow that exact path. Instead of converting hydrogen into electricity through a fuel cell, the hydrogen would be burned directly inside an engine, with injected water used to control the combustion process. Because of that, supporters of the idea argue that Musk wouldn't necessarily be reversing his position. He could still oppose conventional hydrogen fuel cells while accepting a completely different way of using hydrogen if it offered real engineering advantages. From that perspective, Musk wouldn't be contradicting his earlier statements. He would be redefining what hydrogen should actually be used for. Look a little deeper, and a move like this could also be driven by geopolitics and economics, not just engineering. The global battery supply chain is heavily dependent on a relatively small number of countries, especially when it comes to mineral refining and battery material production. China holds a dominant position in many parts of the lithium-ion value chain. That creates risk for any automaker trying to scale production into the tens of millions of vehicles per year. Hydrogen is different. It isn't a free energy source that's simply available everywhere, but it can be produced through a variety of methods, including water electrolysis or natural gas conversion, depending on local conditions. That means supply can potentially be distributed more widely. If Tesla integrated hydrogen into its ecosystem, the company would gain another energy option and reduce its absolute dependence on batteries and battery minerals. For the extremely ambitious manufacturing scale Musk has talked about in the past, diversifying energy sources could have major strategic value. In hydrogen technology, one of the competitors that comes up most often is Toyota. The Japanese automaker has been investing in the space for many years, developing the Mirai and building a large patent portfolio related to fuel cells, hydrogen storage, and fuel management systems. If Tesla followed the conventional fuel cell route, it would be entering a field Toyota has spent decades preparing for. But a hybrid system combining a hydrogen combustion engine, electric motors, and water injection would take Tesla in a different direction. Instead of converting hydrogen into electricity inside a fuel cell like the Mirai does, the vehicle would burn hydrogen directly to create mechanical power while using electric motors whenever instant torque was needed. If technically viable, that approach could help Tesla avoid competing directly with Toyota's core fuel cell technology. It could also force competitors to rethink their own strategies. The Toyota Mirai is known for long range and quick refueling, but high vehicle cost and a limited hydrogen station network have kept sales relatively low. If Tesla could offer a hydrogen hybrid vehicle with around 500 horsepower, more than 600 miles of range, and a price similar to today's premium electric cars, the consumer appeal could be enormous. A vehicle that is cleaner, powerful, fast, long range, and competitively priced is pretty much the formula every manufacturer would love to achieve. Fuel cost is another major part of the equation. Hydrogen sold at commercial stations can currently be extremely expensive, especially in markets like California. For Toyota Mirai owners, high fuel prices can make the cost per mile less attractive than either an EV or even a gasoline car. But Tesla's hypothetical H-supercharger concept is based on producing hydrogen directly at the station through electrolysis using excess solar power or low-cost grid electricity. If Tesla could really cut hydrogen costs by 30 to 40% through on-site production and megapack energy storage, the economics could change significantly. Tesla would not only reduce its dependence on the fuel supply chain, but it could also turn excess electricity into a product that could be stored and sold. What makes this perspective interesting is that Musk hasn't necessarily opposed hydrogen as a chemical element. What he has opposed is the way the industry uses hydrogen through too many conversion steps and too many efficiency losses. While the market argues over battery or hydrogen, Musk could theoretically choose both if a combined architecture worked better. Future Tesla vehicles could use electricity, hydrogen, or some combination of the two, depending on local infrastructure and driver needs. In a city with a dense charging network, the vehicle could run mostly on electricity. On long-distance routes or in regions where hydrogen infrastructure is strong, the hydrogen system could take on more of the load. Under that vision, Tesla would no longer be an electric car company in the traditional sense. It would become a global mobility and energy platform. There's also a philosophical side to that transition. Musk has said many times that the goal shouldn't simply be reducing harm, but increasing humanity's potential. From that perspective, the idea of a water-injected hydrogen engine isn't just about reducing carbon. It can also symbolize the willingness to rethink an idea when new evidence or new technology appears. Something that was once rejected can be reconsidered when circumstances change. That is also pretty similar to Tesla itself in the early 2000s. The company was doubted and mocked, but eventually forced the rest of the industry to follow. Politically and economically, having multiple energy options would also give Tesla more independence. Modern batteries still rely on lithium, nickel, graphite, and other materials. Hydrogen, by contrast, can be produced in many regions if water, energy, and infrastructure are available. That could become especially important if Tesla continues pursuing production levels in the tens of millions of vehicles per year. Depending on a single resource chain could become a serious bottleneck. If part of the energy demand shifted toward hydrogen, pressure on battery supply could potentially decrease. At the same time, the company could become more resilient to commodity price swings and geopolitical conflict. Some analysts might call this a dual strategy. Batteries protect the present, while hydrogen becomes an option for the future. In the short term, Tesla remains one of the biggest names in electric vehicles. But in the long term, if countries like Japan, Germany, Spain, South Korea, and others continue expanding hydrogen infrastructure, a company that owns the vehicle technology, software, batteries, and refueling network could have a major advantage. Instead of waiting for third parties to build stations, Tesla could create its own infrastructure just as it did with superchargers. That's an advantage many traditional automakers have never built at the same scale. Another factor that can't be ignored is Elon Musk's very unusual media strategy. Whenever videos or stories about a Tesla water engine start appearing on technology channels, they spread quickly because the idea naturally triggers curiosity. Musk sometimes neither confirms nor immediately denies speculation like this. That silence encourages the community to debate, analyze patents, inspect photographs, and hunt for tiny clues. In some ways, it resembles the mystery Apple used to create before new iPhone launches. One post, one comment, or one patent filing can generate millions of views and endless discussion. So even if the hydrogen rumors are still only at the idea stage, they can generate enormous media value. Suddenly, the Tesla community starts feeling like the early days again. Fans keep asking, is the water engine real, or is it just marketing? Is Tesla genuinely testing hydrogen, or is the community simply extrapolating from technologies developed somewhere else? But from another perspective, the answer may not even be the most important thing. What matters is the imagination the idea creates. It reminds people that the future of transportation may not be locked into a single choice between lithium-ion batteries and fuel cells. Even if the system never gets beyond the laboratory, it could still push engineers around the world to explore hydrogen engines, water injection, thermal management, and multi-energy hybrid systems more deeply. The history of technology rarely moves in a straight line. A solution can fail at one point in time and then become practical years later after materials, software, or infrastructure improve. Tesla itself went through something similar. It started as an electric sports car company that many people dismissed as an unrealistic experiment, and it eventually helped turn electric vehicles into a global industry. So it isn't hard to understand why some people are wondering whether hydrogen could become the next chapter. If history repeats itself, the ideas people doubt today could eventually become common knowledge. Maybe one day drivers will sit inside a Model 3 or Model Q, see a message on the screen that says something like, hydrogen system active, water injection stable, and feel an almost silent powertrain move the vehicle hundreds of miles without relying entirely on the battery. If that ever happens, people might remember that the whole thing started with an idea that sounded completely insane. But when you really think about it, many of humanity's biggest technological leaps started with ideas that sounded impossible. Electricity, the internet, artificial intelligence, and electric vehicles were all doubted at one point when people questioned whether they could ever work at large scale. That's why the most interesting part of Tesla's so-called water engine story may not actually be the engine itself, or hydrogen, or even water injection. The real message is about the way humans look at limits. A limit can survive for years, but it usually can't survive forever once someone starts asking the right question. The rumors about Tesla and a hydrogen engine may never become a commercial product, and any future system could look very different from what people are imagining today. But the idea of combining batteries, electric motors, hydrogen, water, software, and renewable energy makes one thing very clear: the transportation revolution isn't over. Tesla could continue using batteries, experiment with new battery chemistries, explore different fuels, or combine several technologies at once. What matters is that the company keeps trying to find ways for vehicles to travel farther, use energy more efficiently, and become less dependent on today's limitations. And that may be the best way to look at this entire story. Not as proof that Tesla has definitely created a fully working water engine, and not as evidence that Musk is abandoning electric vehicles. Instead, it is a hypothesis about how Tesla could extend its electrification philosophy by adding another energy source. If hydrogen can be used more efficiently, if water injection can solve problems involving heat and knock, if the infrastructure can be integrated into the supercharger network, and if the cost can actually become low enough, then Tesla would have every reason to investigate it. Elon Musk has built much of his career around questioning things that most industries treat as obvious. He asked why electric cars had to be slow and boring. He asked why rockets couldn't be reusable. He asked why cars couldn't receive software updates like smartphones. So if one day he asks why a vehicle should have to choose between electricity and hydrogen instead of using both in the smartest possible way, that wouldn't exactly be surprising. Maybe that contradiction is what makes the story so interesting. A man who once called hydrogen a terrible solution could potentially become someone who finds a completely different way to use it. A company that once bet everything on batteries could decide to reduce its absolute dependence on batteries. And an industry that seems divided into two clear camps, electric vehicles and hydrogen vehicles, could eventually converge into a combined architecture. If that day comes, Tesla wouldn't simply be creating another car. It would be proving that technology doesn't always advance by completely destroying old ideas. Sometimes an idea that failed before simply needs to be placed inside the right ecosystem, paired with the right software, and introduced at the right moment. The internal combustion engine might not disappear completely. It could be reborn using a different fuel. Hydrogen might not replace batteries. It could become a tool that supports them. And electricity might not be the only energy source of the future. Instead, it could become the central system coordinating several different energy sources. That's what makes the idea of Tesla's water-injected hydrogen engine so interesting. It isn't just a story about a new engine. It raises a much bigger question about how future transportation will actually be built. Are we going to keep searching for one single technology that replaces everything else? Or will the future belong to systems that combine the strengths of several different technologies? If Tesla chooses the second path, we may be watching the company evolve from an electric car manufacturer into a true mobile energy platform. Batteries could handle short trips and deliver instant power. Hydrogen could support long-distance travel or heavy loads. Software could decide how energy should be distributed at any given moment. Megapacks could store electricity at stations. Solar power could provide part of the input energy. And superchargers could evolve from places where you simply plug in a cable into full energy centers capable of storage, production, and distribution. In that kind of architecture, The vehicle itself would only be one link in a much larger system. And in many ways, that's already how Tesla has developed over the years. The company doesn't just sell the Model 3 or Model Y. Tesla also sells Powerwall batteries, Megapack systems, solar energy products, the supercharger network, and energy management software. Adding hydrogen, if it ever happens, would simply extend that same philosophy. In the end, whether the future actually moves in this direction or not, the story highlights something Tesla has always been extremely good at: getting the entire world to debate a future that doesn't exist yet. Sometimes the debate starts with a real product, sometimes it begins with a prototype, and sometimes it starts with nothing more than a rumor bold enough to make millions of people ask questions. Maybe one day we'll look back and realize the Tesla water engine was simply an interesting chapter in the history of technology concepts that never became reality. But it's also possible that part of this idea eventually appears in a future powertrain, even if it looks completely different from what people are imagining today. Technology rarely develops exactly the way early predictions say it will. It changes, combines with other technologies, and evolves until something practical finally emerges. And if one day you step into a Tesla, watch the system automatically choose between battery power and hydrogen, hear a quiet engine running somewhere behind you, while the electric motor delivers instant acceleration, you might remember the time when people laughed at the whole idea. You might remember that it was once considered almost completely insane. But the history of progress is filled with ideas exactly like that. Airplanes were once considered impossible. Cars were once treated as toys that could never replace horses. The internet was once doubted as a serious commercial technology. Electric vehicles were once dismissed as slow, expensive, and impractical. Artificial intelligence once belonged almost entirely to science fiction. So maybe the real point of the story about Tesla, hydrogen, and water injection isn't whether Elon Musk turns out to be right or wrong, and it isn't about what year a particular engine might reach production. The bigger issue is whether we're willing to question the limits we've already accepted. Because a limit only survives until somebody figures out how to ask the right question. And if the history of technology has taught us anything, it's this: the ideas that sound crazy today are sometimes the very ideas that end up shaping the world tomorrow.